their emotional synapses will challenge them. So, 5 Samurai, what's your eternal rejection? Number 1. So, emotional synapses, please, you can start your challenge. Problem number 8 is challenge. Do you accept? Yes, that's nice. So the report will be problem number 8 and the position. Who is opponent? Opponent will be emotional synapses. Okay. Could anybody turn the presentation on, please? Yes, please. So this the right button for forward. Okay. This back. Yes.
Yes.
Thanks.
Excuse me. How can I go right?
Well, it's really weak. In the middle. Ilya. Please announce your name.
Hello everyone. My name is Maoko Takenoshita from Tokyo Institute of Technology, and I'm going to have a presentation about problem number 8, 670 tons of paint in the world, from 5 Samurai. So now let's begin my presentation. So I show some foods and cosmetics here. Ham, sausage, red candy, strawberry jam, lipsticks, and Starbucks strawberry frappuccino. Do you have any ideas of this common point?
They all red.
Yeah. Oh, sorry. Excuse me. Yes, lead. These all have lead pigment. So this lead pigment from carmine. This carmine has a bright lead pigment and produced from scale insects. And these pigments are used for cosmetics, foods, beverage, a lot of types of products. So here I show this common chemical structures. So what is carmine made from? So carmine is from insects called cochineal. And cochineals are mainly harvested in Peru and Canary Islands on a plantation of blinking pear coconuts. And how to make this cochineal pigment? First, dry and boil these insects, and then in ammonia or sodium carbonate solutions. Can you imagine that about 140,000 insects for producing about 1 kg of calamine. That's a lot of bags. So your juice or candy might have a little calamine as well. But calamine is very useful and used in all over the world, but it also had some problems. Here I showed some problems. The first is it has a limitation of the volume of dye. As I showed the number before, it needs a lot of cochineal insect to make a red pigment. Plus, some people fully refrain from consuming animal products, including animal-derived substances called vegan. They have some concern to have some foods or use some have products made from cochineal pigment. And while it has a limitation of the volume, amount of pigment, its demand is growing very rapidly in the world. And finally, it has some health problems. So here I showed some problems in the world. People who had some foods, including calamine, have severe allergic reactions or anaphylactic shock. So in the USA, until 2019, calamine was classified with natural dyes. But after this accident, calamine is required to be listed on the ingredient label. So when you find some food and then turn back and see the ingredient label, you can see calamine pigment on the label. Plus, in the in the EU, the use of calamine in foods is not banned, but the use of calamine in foods has been discouraged by the European Food Safety Authority. So we need some So we need some solutions for replacement of this pigment. Here I show these slides to this problem. I came up for this solution. Here, this is astaxanthin. This is the color of crustaceans like clams or lobsters or shrimps. And the color of most crustaceans are responsible of various carotenoproteins. And here, this is the structures of astaxanthin, and the two molecules of astaxanthin linked to the hydrophobic interactions with the G and H stacks of beta crustaceans. And then this is also the structures of astaxanthin. And the very important things that before boiling shrimps or clams, their color of skin is like a violet or black or something like blue. But after boiling these shrimps or clams, the color changed to the very bright red. This is because the pigment of their skin includes the complex of carotenoid and protein. And after boiling crustaceans, these carotenoid and protein separated, and carotenoid has the big red pigment, so their color changed to red. Sorry. So here, this table shows the change of the maximum lambda, and first they two classicizing its color is blue or violet, but after boiling or add heat, they became red. So
excuse me, you have 1 minute to finish.
Okay. So here is the wavelength shift of acetylysins. So when we add some heat, and the classitysin cause denaturation and a release of acetylysins cell color. And then I don't have enough time to do experiments, but here is the purification of classitysin. So you can make a lead pigment from the shrimps or clams with using this method. And here is the conclusion. So acetylysins can replace the carmine as a useful lead pigment, and these pigment is from the food, so it's safety, and of course we can save the wasted shell, so it's really eco-friendly pigment, I think. Yeah, this is the difference. Thank you for listening.
Thank you. And it's time for clarifying question from the opponent. You can ask clarifying questions from your place, and also each member of team can ask clarifying questions.
Excuse me, you first said about that carmine is not eco-friendly. Also, you said that carmine has caused a lot of health troubles. But you hadn't show us statistics, of course. But okay. And also you said that carmine is rather hard to extract. But you haven't said about health problems. What health problems can cause? You showed us, and why it is eco-friendly if we take it from shrimps and other? Why bugs are better than shrimps and?
Please do not answer. Well, I'll try to explain again. Just before the presentation, you can ask a question to know something that you probably misunderstood or didn't see, like the mass of gorillas was mentioned in nanograms. Is it true or not? Is it correct or not? Is it what you see? And the clarifying question often needs just an answer or yes/no answer. So the questions you ask are good and reasonable, but for polemics. And I want to point out to all teams. So if you have any clarifying questions
okay, I
about...
just thought I haven't seen something and I misunderstood, but it's a rather big trouble. Everything is clear, and I wanna...
Yes, you want to proceed to your opponent's speech, yes? Yes, thank you.
Thank you.
You can sit here.
Okay. Hello, my name is Milenko Maria, and I present the team Emotional Synapses. As I am happy to hear this solution. It's very interesting. Really rather interesting decision, but as I already said, this solution has a lot of troubles that I can't understand and connect between itself. But first of all, the question that I already asked, why bugs are better than shrimps? Why killing of thousands of bugs is bad stuff, and killing of such a quantity of shrimps is not bad stuff? Why is it still vegan? Why it is still eco-friendly? Also, you haven't said about, or I couldn't see it, but about quantities of extractions. How many shrimps shall you kill to get 1 kilogram of your due? Is it connected with bugs? Another trouble that I saw, maybe about catching shrimps. Bugs are not in the sea. Bugs can't run away such fast as shrimps. And I don't think that bugs can extinct, and they seek about ecological troubles of whole sea, oil collapses, and such as shrimps, lobsters, and others. Lobsters are really different. Some species of lobsters are close to be in the Red Book already, and you suggest us to kill it to get due. I think it's economically not very good decision. Improve me if I'm wrong, but I think it's trouble for your decision. Also, about health problem, you said that carmine can cause allergic reaction, such as everything in our world, but okay, you haven't said how much statistic of allergic reactions to carmine and such as. And you haven't said about endured. Can't it be allergic, and why it's more healthy than carmine? Also, you couldn't introduce us ways of extraction your due from the shrimps, lobsters, and other animals. How we can do it? Why is it economically better or worse? I don't understand. If carmine is economically wrong, why your due is economically better? Why is it cheap less? Is it only your opinion, or you have any data for that? Also, I already said that it's sea animals, so we have some troubles about catching of it. Can we? I think that sea expeditions, sea hunt is rather expensive stuff, and also it can cause to more and more fuel disasters in the sea. Also, you couldn't tell us about other dews that can be used. Only carmine can be red and only your dew can be red. Why is your dew is better than another dews, and why carmine is worse or better? You haven't showed us another premier. Another examples.
So you have time only for last statement.
Yes, and I thank you for your attention, and I want to hear your answers about that.
Thanks a lot for your position. So it is now time for polemics, and as always, both of you will have 5 minutes. For report? Yes, of course you can. Yes, the reporter can come to a team and to consult for 1 minute. It is a rare occasion to have a timeout, but regulations provide this opportunity for a reporter. Important team, please. So it's time for a discussion for polemics.
Okay, thank you for asking some nice questions. First of all, you mentioned that why do I have to do I have to kill shrimps or other animals to make a pigment instead of a carmine? And I think we don't have to kill them because the pigment that I proposed is that we can make pigment from the shell. So if you after eating some lobster or clams, you don't. Some people eat it, but usually we don't use that. We don't eat till that shell. So I like to use or reuse that shell. So I don't have to, so we don't have to. Yes, of course we kill for it, but not kill for making pigments. That is one point. And you also pointed out the meaning of the economical purpose, and we can, for example, we also make some pigments from the foods, like potato or purple cabbage, but they are all from the farming. But this pigment that I propose is from the ocean, and also I will show some data. I came up some foods like these grapes, purple cabbage, red onion, but sorry.
Can I see it again? Your what you wrote?
Yeah. For example, grapes. Its skin of grapes is good. No, it doesn't have a light stability. And for example, purple cabbage, it has a good stability, but it doesn't. It has a unique smell of cabbage, so it doesn't good for pigment. Also, red onion, it doesn't have a durability, or it also has a strong onion smells. So I have.
Еще раз вперед. Again, next, please. I just wanted to understand your position.
Okay.
Sorry.
So class, and these foods depends on the pH. So if these foods are only used for acid foods, so if you wanna use base foods, the color turn to yellow or green or blue, not red. So these foods can be used for red pigment. So that's why I make this solution. Plus, I also did some experiments, like I dyed some shoes with red onion pigment, but it smelled very bad like onion, and and it doesn't last its color so long time. So I also show this data that red onion or other foods that can make red color doesn't fit to solve this problem. Yes. And yeah, do you have any other
Yes, dying shoes are really adorable, and I just wanna the same already. But you haven't answered about the main question, quantity. How much cabbage or onion or other stuff you shall use to get dew? How many does people eat so much shrimps or lobsters or other to use its cover to make dew in such quantities as carmine is produced? And also you said that we don't kill animals for just beauty. We kill it for food and then use other. Recycling of waste is awesome idea, but little question. Does carmine use only for beauty? Doesn't it have another applications in our life? It's not killing only for beauty to my mind, but okay. Another question, you said ocean shall us give more than Earth, as I understood, am I right? Well, but it costs more, it's more dangerous for people who make it, who catch it, and another. And the ocean animals are such animals as an Earth, and it can finish at one moment. It can be finished. but to my mind, we can't replace wild shrimps by domestically made shrimps. And another one question that I can ask is great question about the form of your compound. Can you show me your compound for a moment? Formula. And next formula, yes. Look at it. It's big, very big, very big. Why carmine we can use as U? Because it can be solved in not very big quantity of water, for example. How can you unlock the problem with absorption of this dew? Can you absorb it that it won't be colloid compound and it be compound that really dew and not the main compound of all volume in that you gave it? But because I think absorption and solubilization is trouble of this compound because it's very big. Is it true or not? And another question about synthesis. Can't we, for example, synthesize carmine or not? Can we synthesize it another way or not? Why shall we take it only from nature? And another question is about frame 18. Next. What? Следующий. Yeah.
Sorry.
To enter this frame, unlock, please. And why grapes have light stability? Why cabbage smell and other? What is the nature of these compounds, and can we change it by extraction? Is smell dew or smell not dew? Smell another compound or what?
Excuse me, the time for polemics for the opponent has finished, and you have 24 seconds to answer some or any of the questions. The opponent's time has finished. You have reporter's time. You have approximately 30 seconds to make last statements and answers.
Okay, you asked me lots of questions, so I just quickly summarize to answer it. You mentioned how can I synthesize this pigment, but this question is that how can we get a new pigment from the red food? So natural red food. So is out of the focus of these questions. And for okay, then
I'm afraid we have no time for the discussion. It's the third.
Not about that. I just wanted to say that I really like your work that you did, and I'm not aggressive to you.
You can put any of your remarks afterwards. So this is the first time both opponent and reporter used their 5 minutes fully. So let's
talk later.
let's thank them for it. And now please the reviewer.
should use microphone. Yeah.
Yes.
Okay. Hello. I want to thank you for your presentation and the position. It was easy.
Please announce us your name.
Well, my name is Alexandra. Well, as for me, it was easy to understand your presentation. It was good structured and pleasant for perception. And it was emotional and bright report with interesting facts and emphasis on social problems. Well, it was good. Well, you had good introduction, but maybe too long, I think. And the reporter didn't mention the advantages of astaxanthin compared to carmine, as I remember, and didn't mention about possibility of allergy of to astaxanthin too. And what about economical profit? Yeah. What about the position? Position was good for me, and well, sorry. The opponent said the opponent noticed weak spots and pointed out the mistakes, but sorry. But opponent didn't suggest the ways to improve solution of reporter. So opponent spoke on. Opponent told us only about mistakes. But yeah, I think it's important in this problem to remember that we know how to grow up shrimps. But no, on the farm or factory, how to grow up them, we know that very well. But we don't know the ways how good ways how to grow up cochinills. Well, and the reporter should explain mechanism of extraction during report speech to avoid misunderstanding, I think. That's all. Thank you.
Thank you for your review. And now it's time for our experts to ask questions, please. If you have any, yes, please.
Yes, the reporter. The idea about astaxanthin, is it your original idea or someone already used that idea?
Thank you for your question. The method to extract a pigment is already reported on the paper, and then our team found that article about the extraction of the pigment, and yeah, so this is already existing.
If she can shortly explain if she has any alternative way to resolve it.
Yes, but I can't show some story. If you want, I can show it to you after this opponents.
Yes. Opponent and the reviewer cannot introduce their own solutions. So we had another question. Yes.
Yes. Why do you? I hope hear about chemical ways or biotechnological ways to get some of the and another. Did you look for this technology in the literature?
It is a question for reporter. Yes.
Yes, for reporter.
Excuse me, I can understand well, so could you make more clear your questions?
the substances, Carmelius,
Yes.
can we, for example, produce it in, for example, biotechnology way, in, for example, Escherichia coli, we needed plasmids, for example, or just chemical synthesis? Maybe. I want to know, did you see it in literature, something? Did you look for it?
Thank you for your question. Of course, I looked at some papers about making pigments, coloring in a chemical or biological way, but it cost a lot compared to producing from the natural insects, and then it needs also time or money, people. So compared to the common from the natural insects, it costs literally a lot. So for now, making common from the cochineal insects is the most common way. Is that my point? Yeah, thank you.
Can I ask a little?
Why not?
My report just said about the biotechnological side of this problem, and I, as chemist, can say about chemical side of this problem. It's in theory, it's possible to synthesize carmine, but for this we can have much more serious technologies because I think we can't do this until somebody made a great mutation and get Nobel Prize maybe for that, because it's a very stable compound, and it's very hard to make this very stable compound in normal and out of normal
So, any other questions? Yes? So, thank you for all participants, and we can proceed to the grade.
Thanks. So, everyone ready? So, your grades for the report. For the report, from the right side, 7, 8, 7, 6, 6, 5. For the opposition, 6, 9, 8, 6, 6, 5. And for the review, 4, 4, 3, 3, 3, 4. Thanks for this stage, and we go on to the last stage of this round. Now the reporting team will be the emotional synapses. And what is your eternal rejection? All-time rejection.
Our eternal rejection is 7.
7. So, via Matryoshka Chim, you can challenge emotional synapses to any problem except 7, please. Except 7. Number 1. Number 1. Do you accept? Yes, we should. Stage 4, tactical rejection, problem number 1. You also can mark it in your protocols. So the next challenge is problem number, after problem number 1, problem number. Can you challenge to the problem number 8 if you... No, by the time being not. Problem number 4. Yes, because problem number 4, you accept, you present problem number 4, yes? Yes, that's nice. It's nice. Problem number 4.
Good day, ladies and gentlemen. Let me introduce myself. My name is Ekaterina Agafonova. I'm from Emotional Synapses. And I present my and my team solution for the problem wind of change. Okay. Wind of change. Okay, the problem of landfills and landfill gases, especially of greenhouse gases, is the main problem of Russian, for example, territory, and the whole territory in this part. Sorry. Okay. If we talk about biological waste, it's always produced gas during its decomposition. So this gas must be collected because the concentration of the gas is unbalances our atmosphere. What gases I'm talking about? It's ammonia, methane, carbon dioxide, hydrogen sulfide, and some heavier hydrocarbons. So we presume that hydrocarbons, as well as hydrogen sulfide, methane, can be oxidized by some catalytic means to water and some other gases such as CO2. CO2 is much less harmful than methane or the hydrogen sulfide. This we can achieve by means of fuel cells. But from the beginning, I can talk you about the landfill. Landfill is an isolated, preferably underground platform on which garbage is buried. We present the construction. The idea of the platform is on the side is cannon that crush the water flow to a final dispersed state that absorbs all our gases. Such little drops can clearly catch our gases. So the phenomenon is called drop transfer. So you see the fuel cell, and before being catched by fuel cell, the gas being dissolved in water carried to the extracts in common stream to filters. But before that, the gas should be filtered and freed from inorganic components. So it's important for inorganic impurities to be, for example, complexed by trilon B or albumin. Very widespread components and very simple filter, I see. Later, the clear from inorganic impurities, organic substance is transported to our fuel cell. Okay. So, thank you for your attention.
Thanks a
That's
lot.
all.
So it's time for clarifying questions. Do you have any clarifying questions for the reporter? Yes, you want to ask clarifying questions or you want to proceed to your position?
I have one.
Yes, please.
In your system, carbon dioxide is
Reproduce it. This is a reaction, chemical reaction, which I haven't demonstrated. It is the product of oxidation reaction. So, this is it.
So you can. 1 minute. So you can see here. opponent team. Yes, please, you can start.
Thank you for presentation. And you said a very interesting mechanism, but I have one question. So as you say, for the first, carbon dioxide is one of the not good for environmental, but your method is make a carbon dioxide. So I think it is not good for environmental. And one more, I think so. Your method is not biological method. Oh, sorry. So, yeah, your method is not biological. So, I think so. Please. Yeah. So, and I think so. As a for example, methane, and so methane is most important for landfill gas. So I want to solve the problem. Sorry, that's all.
So did you finish your closing speech?
Yeah.
Yes, thank you. And now we proceed to polemics.
So, thank you for your questions. First of all, I can say about non-biological presentation. I think that it's not bad point, but it's not all at all right. I mentioned the reaction of complexation that is mostly biological. That's proteins, lipids, for example, biological substances that clearly absorb metals, hard metals. So I didn't clearly understand about methane. Could you please repeat the question?
Thank you for answer.
Is it answer?
Yeah. Thank you. Okay.
So, Paul, do you have something to add to polemics? No.
Yeah, I don't have.
Yes. But the reporter also has obviously a lot of time to make some statements.
Okay, what is I should say about the CO2, carbon dioxide? As I said, it's a little harmful gas, but different to methane, which has coefficient of greenhouse harm is 21. Carbon dioxide is 1. So compare. Carbon dioxide is not harmful in that quantities which produce by the system. So carbon dioxide is the gas that we need. The deal is in balance, as I said.
No. The reporter wants to have time off. No?
Maybe yes. Yes, please.
Yes, please. You have 1 minute.
I have to add something.
Yes.
My system, that landfill, is closed system. It is isolated and by means of ventilation through the filter system is connected to the atmosphere. So I think that due to fuel cell is totally unharmful system too, it's that project could be realized in the center of city.
Yes, anything to ask or anything to add? So, thank you for your discussion, and we proceed to the review.
Работает, да? Работает, нет? Или вот? Oh, okay. Hello, my name is Margaret. I'm a reviewer from the Screams of Watson team, and I consider the report is good, but there is some mistakes. The first one, theme wasn't related. I consider that it was structured but not so well illustrated. Material in presentation isn't so easy to understand because there is a lot of text and sometimes I didn't see keywords. So what's about opponent? Opponent wasn't so good because he didn't know the main problem during the presentation, that theme wasn't related. When was the polemic? Polemic really well tried, and I didn't know any issues in their polemic, but it wasn't so good as I wanted to be. I think that's all. Thank you.
So thank you for your review. And now it's time for questions from jurors.
Okay.
Please.
And the question from me. It's hard. For example, how do you think collect these gases? How we should collect? Because solid waste in Russia, for example, it's meters. It's dozens of meters of waste. How we should collect gases from the middle of it, for example?
As I said, the wastes are decomposed, and through decomposition, gases are evaporated. So, when the matter decomposed, the volume is changed. So, I see that landfills are extremely big, enormous. So our wastes may be localized and so much more smaller than the polygons around the city, for example. So its height is under the ground.
Now, didn't you think that your method with the water is too expensive? Did you try to have some math with the expenses for those kids?
No, we have math about this project, but there is a lot of math if we go to concrete place and concrete accurate numbers values are so the materials used in the fuel cell are not so rare. For example, methanol is a polymer that was invented in 18th, 17th, 70s. So it is generally produced every year. And the main problem is hydrogen, pure hydrogen. But as I said, with the catalyze, we can solve this problem and use carbon
dioxide. Carbon dioxide.
No, dioxide. Organic components. Butan, metans, propans, so on.
Alexander, can I tell how it's in real? I'm a sufferer of
well, what you can do, you can tell us your opinion about the scientific context of a problem or of a proposed solution.
Okay. You didn't catch the problem. That gas concentrates inside of municipal solid waste, and there is and there is change processes from aerobic to anaerobic processes, because there is no oxygen left inside the mass of waste, and so in real, people use pipes and collect this gas, and most time they are burn this gas, but more wise people use on electric stations, because more than 50% of the gases is methane, and it's quite good for electric stations. That's it.
Thanks a lot for your answer.
Could I answer?
Yes, please.
Yes, we know about the solution of the problem. It's quite good. We know that, but we have lucky to explain our vision. So we thought and we present. And our solution is to absorb gases. So what is it?
It's your solution, but it's hard to in engineer. It's really hard to take place in real world. I think.
Yes, thanks a lot for your questions and answers. I think if there are no any questions, we can proceed to grades. So, yes, let's thank all of the participants of this stage. So, if everyone is ready, let's see your marks for the report. So 6, 8, 7.
Each side. So it is a mistake. Actually, it is 6. Sorry.
Okay. It is 6, 6, 7, 4, 4, 6. For the opposition. 6, 3, 2, 4, 3, 3. And for the review, 4, 2, 3, 2, 2, 4. So that's all for the first round of science fights. Now we are going to have our lunch break. We will have second round. Here the jurors in general will remain. The teams will be mixed up a bit, and Biomatryoshki and Watson Screams will stay here for the second round, and 5 Samurai and Emotional Synapses will move to the section number 2. I would like to remind you that after the end of the second round, you will have to come up with your preferences for the final science fight. I ask all teams to do that, and I think according to our grades, we do not have any favorites or any leading teams by the time. So the second round could change everything, and by the time all teams have equal chances to proceed to the final. So now it is time for lunch break. Jurors will have their lunch at the Institute of Basic Biological Problems, and I guess Mr. Daniel Aladdin can lead you there. Our participants will have lunch here on the first floor, but I think it will be available in 20 or 30 minutes. And after that, according to our schedule, we shall start the second round at 3:30. 15:30. We will start the second round. So thanks a lot for your participation. Let's have a break.